Right after the last review video, we introduced the full fly algorithm. So instead of having the fly fly from destination to destination in a straight line, it selects sub-destinations along the way to fly to. So the fly globally has a goal, but locally it kind of meanders about. So this is the implementation of that. We draw a circle somewhere between the fly's current location and the destination, and select a random point inside of that circle to be the sub-destination. So this was just setting the sub-destination. We didn't actually fly to it until the next video. It was pretty simple to make that change. We basically replaced the destination with the sub-destination so that the fly would fly in a straight line from the location to the sub-destination. The only tricky part there was when to update the sub-destination and the destination. So we would set a new sub-destination anytime we reached the old one, which was the same logic that we had for the destination. The only new logic on top of it is that at the end, when the sub-destination is equal to the destination, we also need to set a new destination. And that was it for the fly algorithm. At that point, we were done with the single fly case. So the next thing we did is tried to make multiple flies. And remember, this didn't work because our fly class has this blocking code, well, this infinite loop in its constructor. So the constructor actually never returns. We remedied that in the next video by adding a fly thread to run that infinite loop, so that the fly constructor is no longer blocking the main thread. It's spinning off its own thread to run that infinite loop in. So this put 20 flies on the screen all at once. And the final thing we did is, I didn't think that was the most elegant thing to do, so we did some fly reproduction where we started with a single fly and had that one make offspring, and those offspring make offspring until we reach the maximum number of flies. And that's it.